Hi. So in this video we are going to discuss what happened when two trains running in the opposite direction try to overtake each other. So let's have a drawing of trains. So here we have a drawing in which we have two trains. One is colored in green and another one is colored in red, right? And I have drawn a line in between to guide us through the directions and also to guide us in measuring length and distances. So this is the green train which is running in this direction, right? And this is the red train which is running in this direction. And each partition on the line actually represents 10 meters. So this much portion is actually representing 10 meters, right? So what will be the length of green train? The length of the green train will be 1, 2, 3, 4, 5, 10 meters, that is 50 meters. And the length of the red train will be 40 meters. Right? It is equal to 1, 2, 3 and 4 partitions of the line. So the length of the red train is 40 meters and the length of the green train is 50 meters. And now let's assume the speed of the green train as 20 meters per minute. I know it is very slow, but we are assuming the speed in meters per minute because the length of the train is given in meters. And let's assume the speed of red train as 10 meters per minute. Right? So these are the assumptions. And first, the length of the train we have assumed as 50 meters. So let's call it as L1. This is equal to 50 meters. And in another case, the length we have assumed as L2. And this is equal to 40 meters. And the speed in first case is S1, which is 20 meters per minute. And the speed in second case is S2, which is 10 meters per minute, right? So these are the assumptions which we have made. And now let's see what happens when they try to cross each other completely. So what will be the situation after 1 minute? Suppose if this is the starting point, let me color it in red. So suppose this is the starting point where the trains are just about to cross each other. They are just starting to cross each other, right? At this particular moment, their front ends are in perfect alignment with each other, and in the very next moment they will be overlapping, right? So what will be the situation after 1 minute? After 1 minute, this red train would have traveled a distance equal to 10 meters. That means the new position of this red train will be, right now it is here. After 1 minute, it will reach here. It would have traveled 10 meters and it will reach here, right? And what will happen to green train? The green train is also traveling and it is traveling at a speed of 20 meters per minute. That means in next 1 minute it will travel a distance of 20 meters. That means the green train which is right now over here would have traveled a distance equal to 20 meters in those 1 minute and it will reach somewhere here, right? So this will be the situation after 1 minute. In 1 minute, their front ends have actually become 30 meters apart. They have actually crossed 30 meters of each other, isn't it? Yes. So in 1 minute, the green train has covered 30 meters of the red train and this red train has covered 30 meters of the green train, right? So what is happening? Here actually the speed at which they are crossing each other is actually the sum of the speeds S1 plus S2. In 1 minute, green train is supposed to travel 20 meters and red train is supposed to travel 10 meters, but actually they have covered 30 meters of each other. That means the speed at which they are crossing each other is actually equal to the sum of both the speeds. So this will be the new speed at which they are trying to cross each other. right? Which will be the sum of both the speeds. And this happens only when they are running in opposite directions, right? When they are running at opposite directions, the distance or the length they cover of each other in unit time is actually the sum of their speeds, right? So the speed is actually getting added. You must have learnt in school that when the two trains are running in opposite direction, we add their speeds. But why do we add their speeds? This is the reason, right? Because when they are running in opposite direction, the length covered in unit time is actually equal to the sum of their speeds, right? Yes. And what about the distance they have to travel to cross each other completely? So when we are talking about the distances, we again have to start from the beginning. So initially this green train was somewhere here and this red train was somewhere over here. They were just about to cross each other, right? So this was the situation 1 minute ago, right? We have talked about the speed. The speed is actually becoming the sum of both their speeds. But what about the distance? So if we assume that this green train is stationary and this red train is trying to cross this green train, red train is running in this direction, of course, in their original direction. And let's now calculate how much distance it has to travel in order to cross this green train completely. So this is the red train and it is running in this direction, right? So this is the point where these two trains are just about to start crossing each other. We have assumed that this green train is stationary and we are only talking about the red train. So if red train starts running, right now its front end is in complete alignment with the front end of the green train, and now it starts running. So its front end starts moving, the whole train starts moving, and it reaches somewhere here. In this position, the rear end of the green train is in alignment with the front end of the red train. And how much distance this red train has traveled? Yes, it has traveled a distance equal to the length of the green train. Started from here, it's traveling in this direction, and its front end has actually covered a distance equal to the length of the green train, right? So distance will be L1. But at this particular moment, the train hasn't crossed the green train completely. So it has to travel some more distance, which will be equal to the length of the red train. Isn't it? Yes. So the distance will be length of the green train, which is L1, plus the length of the red train, which is L2. Right? Yes. Want to see it again? Yes, we will do it once more so that you clarify all your doubts and the question why we add lengths of the trains when two trains are trying to cross each other in opposite direction. So this was the original position, and then it is traveling towards left. So it comes till here. The front end has covered the distance equal to the length of the green train, and now also they haven't crossed each other completely, right? So it has to travel some more distance so that its rear end also crosses the green train, and in order to do that, it actually has to take out its whole length out of the green train, right? So in order to do that, it has to travel a distance equal to its length. How much distance it is traveling? It's traveling from here till here. Front end is coming from here till here, and this is equal to the length of this red train, isn't it? That is why we are doing distance which has to be traveled equal to length equal to the sum of both their lengths, right? So this was when green train is stationary and red train is running. Now let's see what happens if the red train is stationary and green train runs. This is the starting point, right? The front ends of the red train and green train are in perfect alignment, and now we are assuming that red train is stationary and green train is running. So let me select green train. I have selected green train. It is somewhere here. Their front ends are in complete alignment, and now it starts running. So it starts running towards your right hand side, and it runs this much distance where its front end gets aligned with the rear end of the red train. And how much distance it has covered? Yes, it has covered the distance equal to the length of the red train. And now it has to take out its whole length out of the red train. So it will again run towards the right, and it will cover a distance equal to its own length. Right? Yes. So what is the total distance covered by this train? Again, it is covering a distance from here till here, and this is equal to, this much is equal to the length of the red train, and this much is equal to the length of the green train. So what is the total distance covered? In this case also, the total distance covered is actually the sum of the lengths of both the trains. Right? Yes. And that is why we add the lengths of the trains when they are running in opposite direction. Right? So how much time will they take to cross each other completely? Time is equal to distance by speed. Right? What is the distance? Distance is the sum of both their lengths. So their lengths were 50 and 40, and the speed when they are running in opposite direction is also the sum of both their speeds. So it will be 20 plus 10, and this will be equal to 40 plus 50 is 90, 20 plus 10 is 30, zeros will get cancelled, 3 ones are 3, 3 threes are 9. So it will take 3 minutes for these two trains to cross each other completely. So this was just the concept,